So what we're going to do here is use Gauss-Jordan elimination to solve that pesky system that we started with. So first thing we can do when we're dealing with this is just bear in mind that we've already done Gaussian elimination. Usually you might not have a nice row echelon form to begin with, but here we're sticking with a consistent example, so we do. Now, from this point, we want to get everything that isn't on that diagonal out of here. The nice thing about having row echelon form to begin with is that we can kind of work from the bottom and go up. So we can see that in that third column, what we'll want to do is essentially the reverse of what we did before. Where when we were going before, we started from the top, went down. Now we're going to go from the bottom up and clean out those columns. So the first thing we're going to do is take the 1 that's in the bottom there and use it to clear out the -7 and the -2. The order you do this in doesn't make a great deal of difference, but we'll go with 3 to 2 first, just because it looks a little bit simpler to hop that way. What we're going to have to do is add 7 times the third row, which is just a 1, and a couple of zeros, because we're already in row echelon form, and get rid of the 7, and then also we're going to have 7 times 1 plus -6, which will leave us with a 1. So our second row is going to get cleaned up and be 0, 1, 0, 6. And then we're going to take that type of thing again and go to the first row. We have to get rid of the 2, so add 2 times it. 2 goes away. We have 2 times 1 plus 0, and you'll end up in the first row with 1, 1, 0, and 2. And when we have that set up, the last thing that we need to do is just clean out that 1. So you see that second row, it's got a 1 in the middle. We can use that one to get rid of the other one. Take row 1 minus row 3. If we take row 1 minus row 1 minus row 2 now, excuse me. I guess I had too many letters. And subtract. The 1 will go away, and in the middle, we'll have the desired 1, 1, 1, 0, 0, 0, 0, 0, 0, and the augmentation is all that's going to be left, where we're taking 2 and subtracting from it 1 to get 1, which tells us that just like before, our solution will again be the set of 1s. X equals 1, y equals 1, z equals 1, where it's just a tiny bit cleaner to see because it's in reduced row echelon form. So really, Gaussian elimination versus Gauss-Jordan, for your purposes, it's a matter of whether you're more comfortable with this matrix stuff or if you prefer doing substitution. Most people are more comfortable with the latter to start and then grow to appreciate the former after getting some practice. But again, practice is going to be key here. It takes a long time, it takes a lot of work to get used to what matrices look like, to get used to how they move around. But I think it helps a bit to think of this as working something like a number puzzle, something like Sudoku, because it has that same sort of flavor, where you have a specific pattern that you're starting with, a specific pattern that you have to end up with, and then a few specific rules that you're applying repeatedly until you end up where you're supposed to be. Or, as we'll see in the next section, can't get where you're supposed to be. Those are 8.2 concerns. We'll get there in a bit.